Ever wonder how your phone dims automatically? Or streetlights turn on at dusk? The secret is the light sensor. It's not just simple on and off. The light sensor is your device's eyes. It's far more complex than you'd think. This video dives into light sensors, from basic structure to how they turn light into data. How do devices see? Let's start with the heart of every light sensor, the photodiode or phototransistor. What are they? And how do they work? A photodiode is a semiconductor diode. When light hits it, an electric current is generated. More light means more current. A phototransistor is like a photodiode, but more sensitive. It amplifies the light-generated current, giving a stronger signal. This is the most basic way light converts into an electrical signal, a truly amazing transformation within microcircuits. But how do devices tell different light types apart? Like sunlight, fluorescent, or LED light? That's where optical filters come in. They're like special sunglasses, only letting certain light colors pass through. By using multiple photodiodes with different filters, sensors measure each color's intensity. That's how they identify colors. Sometimes, they can even measure color temperature, helping devices understand if ambient light is warm or cool. So, where does the electrical signal from the sensor go? It needs processing for the device to understand and act. The analog signal from the photodiode goes to an analog-to-digital converter, ADC. It becomes digital data. The chip understands. Then, the digital data goes to a microcontroller. Here, complex algorithms analyze it and make decisions. For example, if light intensity is too low, the algorithm orders the screen backlight on, or streetlights to illuminate. But some light sensors are even more complex. They can differentiate between visible light and infrared light. This is how devices can operate in complete darkness. Think of iPhone's Face ID. For example, this system emits invisible infrared light. The infrared sensor captures it, creating a 3D map of your face. Amazingly, this technology isn't just for phone unlocking. It's also used in night vision and autonomous robots. The future of light sensors goes even further, from optimizing energy to smarter computer vision. Imagine a device not just adjusting brightness, but recognizing emotions through facial expressions, or even seeing material structures hidden beneath surfaces, unlocking endless possibilities. From tiny photons to smart device decisions, the light sensor is truly the eye of the technological world. Next time your phone automatically adjusts brightness, remember the complex story behind how it sees you. What crazy future applications do you think light sensors will have? Share your thoughts below.